Hello everyone. Today we're going to look at this leaders in an array question challenge problem from GeeksForGeeks. It says write a program to print all of the leaders in the array. An element is a leader if it is greater than all of the elements to its right side. And the rightmost element is always a leader. For example, in this array, the leaders are 17, 5, and 2. So before we get started on this, let's take a look at how we would approach this. I've got that example array written here, 16, 17, 4, 3, 5, 2. And our task is to find the leaders. And we know that 2, 5, and 17 are the leaders because it told us that. But how did it know that these are the leaders? Well, let's think about one way we could do this. One way we could do this is go through each element one at a time and check all of the elements to its right to see if any are greater. And if none of them are greater, then we know we have a leader. So let's do that with 16. So 16, our let's make that our current number to check. To check is 16. Okay. So let's go to the right and check if any of these numbers are greater than 16. How about 17? 17 is greater, so we know that 16 is not a leader. So let's check 17. 17. 4 less than, 3 is less, 5 is less, and 2 is less than 17. So we know 17 is a leader. How about 4? 4, 3 is less, 5 is not less though. So 4 is not a leader. How about 3? Immediately we know 5 is greater than 3, so 3 is not a leader in this array. How about 5? The only element to the right of 5 is 2, and that's less than 5, so we know 5 is a leader. And 2 is the rightmost element, and there aren't any elements to the right, so we just call it a leader as well. 17, 5, and 2. So there we go. We got the correct answer. But how many steps did that take? Well, for each element, we know we had to check at least, or at most, we'd have to check all of the elements to its right. So we have to go through the elements one time, just with each number to check, and then one time again for each number to check all of the numbers to the right of that number. So what that results in is one loop through all of the numbers times another loop to check each number to the right of the number we're checking, which means that the complexity of this is n squared. Because for each number, we'd have to do at least, let's do the math exactly here. Since we have 6 numbers in our array, we have to do at most 36 steps. And in reality, it's not quite that many, but just knowing that the process has to loop through all of the numbers twice for each number, we can say that it is an n squared complexity. Okay, So that's one way to do it. Let's show you the Python of how you would do it that way. So here I've got a little tester, and it gives us an array of integers, and we have to return an array of integers, and our job is to implement this. And I have some tests set up, so let's run the tests. It says 2 tests failed. So I don't have very many tests here, but this is a pretty simple problem. And I've written enough tests to be fairly sure that an implementation is working, if it is working. So let's do this using this n² complexity technique. So we know that we have an array of integers, and we want to loop through the array of integers. Well, first we're looking for the leaders. So let's say leaders equals an array. And we're going to end up populating that array with leaders as we find them. So we want to loop through each number, and as we loop through each number, go through all of the numbers to the right of it. So first we need to loop through each number. And I want to have the index of that number so we can know where to start our second loop. So I'm going to use, for I in range, length of array of integers. Okay, there's our first loop. Let's say current number equals array of integers at I. That'll grab our current number. That'll be the one that we're considering right now. And now we want to write another loop to go through all of the numbers to the right of that number. So let's start another for loop for, let's use j in range. And here's where it gets a little tricky. We need to go from, let's say if we're dealing with 16, start at 0. 1, 2, 3, 4, 5. This is the index. If we're considering 16 and that's our current number, we want to start at 1 and end at 5 in our checks of numbers that are to the right of 16. But we want that to work for any of these numbers. So if we're working on 4, we want to start at 3 and go through 4 and 5. So we need to check, or here's how we're going to do that. For j in range, the start is going to be I plus 1, because if I is 1, we're looking at 17, we want to add 1 to know where we should start, looking at numbers to the right of 17. So that's where the I plus 1 comes from. The start and the stop needs to be the length of array of integers, and we want to, you know what, we just want to go by 1, so I'm going to leave that step option off. Okay, for j in range I plus 1 to the length of the array of integers, what we want to do here is check if any of these numbers, let's make a variable for that number, rightward number equals array of integers at j. Now we want to check if the rightward number is greater than or equal to the current number. Then, if that is true, current number is not a leader. Okay. So that's going to be our checks, but we need to know when we should add the current number to our liters if we get through all of these numbers and none of them have been greater than. So I'm going to make a little Boolean to keep track of that. Is liter equals true. I'm going to default that to true. Sorry, I'm writing Python. I have to capitalize my Booleans. That's true. So if this number is not a liter, then we can say is liter equals false. And since we found our answer in this inner loop, we can break out of that loop because we don't need to check, like for 16, we knew that we could stop checking after we saw that 17 was greater than 16. So we don't have to check any of these numbers past that. That's why we can break out of this inner loop. Okay. And once we get out of that loop, we need to check. Oh, sorry, this is the inner loop. Once we get out of that loop, we need to check if is liter. So if is liter, if this variable made it through the inner loop without being changed to false, then we do have a liter. So let's add or append our current number. Oh, whoops, sorry, liters. Liters.append current number. We're going to add our current number to our liters. And that is all of the process there. So at the end, we can return liters. All right. Let's try our tests. It says all tests succeeded. There you go. So that works. The problem here is we have a for loop inside of a for loop. And that is what's giving us this n squared time complexity. And n squared is not very good in most cases. A lot of times it's unavoidable. But here is one of the places where we can do much better than n squared. So let's think about our problem again. This is the old way up here. Let's see if we can do it faster this way, or faster down here. I'm going to redraw our array 16, 17, 4, 3, 5, and 2. So the clever way to do this is we need to start at the right side and slowly move to the left. And whenever we see a number that is higher than we've seen before, that number is always going to be a liter. So let's see how that works. We're going to start over here at 2. We need to keep track of our highest seen. So highest seen so far. And current number to check. Okay. So we're looking at 2 right now. Starting at the right, we're going to the left. Looking at 2, the highest we've seen so far is nothing. This is the first thing we've seen. So we are going to default to yes, that is a liter. So 2 is a liter. And the highest we've seen is 2. All right, now let's look at 5. Is 5 greater than the highest we've seen? Yes. So 5 is a liter, and we need to update the highest we've seen. Now it's 5. How about 3? Is 3 greater than 5? No. So it is not a leader. And the same thing happens with 4. It's less than 5. So it's not a leader. Sorry, at this point, we have gone this far. Let's go over to 17. Is 17 greater than what we've seen? Yes. So we need to mark 17 as a leader and update our highest seen. And then we can go over to 16. Is 16 greater than 17? No. So that is not a leader. And look at what we have left. 2, 5, and 17. Which is exactly what the answer is. 17, 5, and 2. Okay. So let's do this in Python. So I'm going to comment out this solve. Actually, here I'll comment this entire thing out. I'm going to move this end comment down here. Okay. So that's the end of that. And now I need to get myself a new solve. There we go. And the input is going to be array of ints. Okay. And this is how we're going to do this. So let's look at our variables we needed. The current number to check and the highest seen so far. So the highest seen, we can make that a variable on the outside of our loop. So highest seen so far. And one way to deal with this problem we had at the beginning, where highest seen didn't exist when we were looking at 2, is to just default it to negative infinity. Because negative infinity is always going to be less than the first element in our array. So that's our little trick, negative math.inf. And that's going to make me import math. Added import math up here. Okay. Now we want to traverse our array starting at the end and going backwards towards the beginning. And Python makes that really easy. Say for item, I'll call it num, for number in reversed r of ints. The reversed is going to start us at the end and give or hand us each element to work with one at a time all the way up to the beginning. Reversed array of integers. We also want to make a collection of leaders to return. Make that an array or a list. Okay. So what was our step here? If the current number is greater than what we've seen, then it is a leader, and we need to update our highest seen. Let's do that. If num is greater than highest seen so far, then we need to say leaders to return dot append num. Okay. And highest seen so far equals num. And then we can return leaders to return. All right. And that is it. it is less code than the other way. It's a little less complicated. You just have to know the trick. So let's run our tests and make sure that I did it right. Yep, all tests succeeded. There you go. Let's talk about the time complexity here. You can see it's only got one for loop, and just from the way that we did it by hand, you can tell all we have to do is run through the list one time, which means every time you add an element, you only have to process one more element, which gives us a complexity of O(n). Now O(n) is way better than n squared, and that's why we are happy about this one. Even though we're a little worried about that one. And that's it. So thanks for watching my video. Comment any questions you have. I'll try to answer them. And if you found it helpful or you're going through this sort of thing in your class, share it with your classmates, whatever. I am just putting these videos up for fun. So I'll see you later. Bye.